Howdy folks. So this lesson today is going to be about how transforms and pivots can affect your modeling. So I'm sure, as some of you may have noticed, as you've been working with modifiers and connecting different pieces, you may have noticed some odd behavior in Blender. So if we know what to look for and we know what to expect, we can set up our objects correctly so we don't get anything unexpected essentially. So my first example, I'm going to be talking about three main subjects is object transforms, mesh transforms, and pivot orientation. All three of those can really affect how your modifiers are displaying and how your objects connect to different objects, such as like curves or lattices. So in my first section here, I'll talk about object transforms. So one of the easiest examples is to show this with the solidify. So these two pieces are exactly identical. The only difference between them is the scale and the rotation has been applied. Their pivots are the same, but otherwise the scale of this object is reading 111, and this one has different transforms on different axes. So this is just something to be aware of when you're using Solidify, because essentially what these modifiers are doing is it's taking this object level transform data and applying it to the modifier. So for example, just to illustrate what I mean, if I have this object and I zero this out, this snaps back into place and you can see it being even thickness all the way around. So say for example, if you're pulling out your thickness and you're like really struggling to get a lot and it's the values don't really make sense, or if you apply a solidify from one object to another and even though you have the same value they're displaying differently, it's definitely because of the scale thing. And just to quickly explain the difference between scale and dimensions here, as I have explained in previous demo, it's very relevant to this topic, so I'll go through it again. But essentially the scale, think of it as a percentage value, 1 being 100%, and it is fully relative to the object you have clicked on. So a scale of 1 doesn't give me information on how big this object actually is. It just means that it's like zeroed out and like applied. So if you need to know the actual scale of an object, your dimensions will be what you want to look at. So as you'll notice, if I move around in object mode, this dimensions isn't going to change. If I scale it up and I go back, if you can see between these two, the values are different, whereas like my scale value hasn't changed at all. So this is going to show in relation to the scene, and the values displayed here are going to be dictated by your scene settings, so specifically units. If you don't want to see metric, for example, you can change to a different size. In terms of what the scale is, 1 is just default to Blender. I have another lesson on if you need to bring objects from Blender to Maya, because there is a scale difference between those two softwares, but I won't go into that now. Point is, it's here if you need to change how this is displaying, but just know that this is unchanged. No matter how many times you zero your object, and just for or I should say apply your object, any just for reference, it's Control A to apply any of these settings. No matter how many times you apply or zero, or there's no way to change this value. It's just going to be absolute and display at all times. So that is a major difference between Blender and Maya. Is Maya kind of has that one channel setting where the dimensions and the scale are kind of together in one value, whereas Blender has them separated, and that's very important in terms of like how it functions with its modifiers and stuff like that. So just keep that stuff in mind. And like I said here, for example, since I've scaled this down, now it's 0.4. Now this thickness is like half of what it should be. So just be aware of those things and how they're going to affect your modeling. So this is for modifiers typically under the generate setting. They will operate a lot better if they are scaled out, or like their scale and rotations applied and zeroed. That's not like a blanket rule. That's just sort of like, that doesn't apply to each and every single one of these. That's just sort of a general rule that if you're getting odd behavior, check your scale and just apply it. So that's an example of when you need to apply your scale in order to have it function correctly. And here's an example of if you do apply your scale, you'll actually break it. So for the object, for example, if I look at these two objects, their scale is exactly the same. They're both zeroed out, so y is, and these lattices as well, they're duplicated, they're the same. But one is acting up and one is fine. And this is because lattices actually require this scale information in order to deform your object correctly. So for example, if I were to duplicate this, this is essentially what I did to receive this result. even if I zero this out, change the location, change the pivot, it doesn't really matter. But if I have this object and I scale it out, it's going to balloon it up because lattices aren't meant to be zeroed at all in order for them to function correctly. So yeah, the moment you zero your lattice, you've broken it. You basically need to create a new one. There's no way to like undo this. And same as for curves, which I'll go over in a little bit. So yeah, if you do that, you basically just need to restate your lattice. So just keep that in mind. Lattices, never zero them out. You need to keep that scale information in order for it to function correctly. So moving on to mesh transforms. So that was object level changes that can affect your modeling. Even if your object is zeroed out, like in the case of these two, woo, hello. Sometimes, sometimes modifiers rely on both information in order to give you a correct result. So in this case, for example, a lot of the times the orientation of your mesh can affect how a modifier will display. So I will explain that how this works here. So screw is a modifier which may seem odd because if you apply it to just like, you would think, for example, if you have a cylinder and you apply the screw to it, you think it would just twist your cylinder. That's not actually how this modifier works. So this modifier requires it. I think it might work with curves. I haven't really used this modifier that much, but it definitely works with geometry. So I just have an edge curve here, and right now I have it just flat, oriented up. Pivot is right in the center, and I want it to do this actual like screw pattern. So the main difference between them is like where this mesh is sitting. Like my pivot, for example, is going to affect this as well because it's the basically the source of where the spiraling is coming from. So if I put my pivot over here, it should indeed mess up because now it's considering this the center of my circle and it's pushing basically the spiral around this point. But say if you want something more like this, where it's like, okay, well, I don't know the exact distance, I don't want to have to snap and guess, but you can drag to get the same value. So if you just, in order to do the exact same thing, you can go into mesh mode, or yeah, your edit mode, and just drag this out at different values. And then this is another way to control it interactively without having to like snap your pivot. Again, this is like the same kind of thing because instead of taking this point and moving it out, I've taken the mesh and moved it out. So I still get the same result where the pivot is in the middle, the curve is going around that pivot, and it's just I've moved the mesh instead of the pivot. So both work. And then in this case, the tube is like quite thick all the way around. It's the same thickness. That's also having to do with the orientation. So if you just rotate these up, a lot of curve type functions work in this way. That create this isn't a curve in this case, but like most curve functions will rely a lot on like the orientation. Like for example, if you're using an object to dictate the shape of a tube or a curve, your orientation will definitely matter in how it gets displayed. So another example of that is the simple deformer bend down here. So for example, if you're making a leaf, you may be tempted to create a plane and flip it up and then apply a bend onto this, which is what I did here. I've basically just created a plane, flipped it up, added some lines so that it can bend, and then I put the bend modifier on there. But I'll notice when I put the bend on there, it doesn't matter which one I select, it's not bending. Doesn't really matter which one, and that's because the orientation of the like the geometry inside that object isn't facing the right way. So the way the bend modifier works is it requires it to be flat on like I guess the z-axis. You know, it needs to be pointed this way. So because my mesh is angled upwards, which is not what I want, I need it to be flat. So in this case, what I did, you duplicate, grab it, rotate it, and then as the moment you get off that 90-degree axis, you'll notice it pop into place. So that's what it's supposed to be doing. So that's what I've done here. And then in order to get it to orientate back to how I originally had it, you just like flip it. You can input RX for rotate on x-axis, input 90 for 90 degrees, and then you have this flat. But if you still want it face up, again, RX negative 90, and then you can flip it back up. Or whichever orientation if you want this to be pointed forward. And now when you bend these, it will actually affect your object the way you expect it to. So if that's another thing, if a modifier is acting up and it's like not giving you a transform that you want, it could very well just be the orientation of your edit mode. So just try going into edit mode, try rotating it, Generally, if you want to stick to 90-degree increments, that's how most modifiers will function a little bit better, just because then you're sticking to like a neutral axis, at least axis, when you're like moving your stuff around. So I don't know why I put a little accent on axis, but anyway, so because yeah, this isn't great for modeling if you just have it like this, because now your orientation isn't matching. But anyway, so in case of bend modifier, your rotation value and stuff like this will affect to how things are getting displayed. So for example, this rotation, it's rotated 180 degrees. If I zero out rotation, it's just going to flip it. Uh, that's just how this modifier works, because I'm applying this value in a positive way. In order to get it to flip the other way but still be like a neutral value, I just need to flip this value. So typically between the settings on your modifier, the orientation of your mesh, the location of your pivot, and the transforms on your object, between those four things, there will be a setting to get the look that you're going for. If there's even one of those things are off, when they needn't be off, then yeah, you might not get it to display correctly. So a lot of experience can help with learning which modifiers work better at what orientations. Like for example, the particles in Blender, the way their system works is typically like Z-axis is up, but for particles specifically, the y-axis is, or like this positive, like yeah, if you rotate in y at 90 degrees, it'll rotate in this direction and be pointed this way, and then your particles will point up. So a lot of it is just learning like the specific behavior of Blender and like the orientations you need to set to in order for your tools to work correctly. I'll do one last set of examples here. So okay, I don't need this. Get rid of that. Close. Okay, so the last thing that will affect, as I kind of showed a little bit previously, is your pivot. So for example, I have an object with an array and then a curve, and these are both exactly the same. The only difference between them is their pivot points don't match on this one, and their pivot points do match on this one, because the pivot of your object is going to interact with the pivot of the curve, and if they aren't the same, it's going to apply that value to the modifier, basically offsetting it. Sometimes that's what you want. Like for example, if you do want it to be like on the curve but just slightly offset, like maybe the curve is like you need it to like connect to the bottom of your object, this is a great way to have the offset, or the opposite, or whatever it is. But if for example, your rotation isn't functioning the way you want, or it could have to do with, for example, which axis you're choosing to deform on, if it's not connecting. But essentially you just, yeah, and in this case I've pulled, just to explain what I did here, since I rotated it around, I've changed the direction the array was moving in. So in order to get it to like cover the same distance that I had before, you have to like pull it out along that axis. So which axis it'll be isn't really worth remembering, because it'll change all the time depending on like your orientation. For example, if I have these two and I rotate this 90 degrees, they're still staying together, but that's because I rotated them together. So in this case, in order to get it to offset in the same way, on this object, it's Y, but on this object, you know what? Actually, it's still Y. All right. Okay, cool. Learned their thing. So yeah, if you want to move things together, definitely move them at object mode. You actually will get to maintain the same orientations. Oh yeah, you know what? It's because I've set the deform axis to be Y here, and on here I set it to be X. So again, that's just another example of like, check the modifier, check which axis it's connected to, check your object, see how that's rotated, see which, like even for the array, for example, that could give me a different result if I had -1 versus 1, and I was like expecting it to go in one direction versus the other. So there's so many different little things that need to hook up together in order to get the result that you're looking for. So let's go over my final example here, which is creating, I've made this before, but this is a good example to show on how things can go wrong very easily. So let's grab this little curve. Let's grab this guy to start with, and I'm going to collapse this down so it's just like one piece of geometry, and I want to make a little flower from this. So if I just start off here with no heed to object or orientation or anything like that, and I just create my my empty, You can rotate around any kind of object. Empties are good to use because they're the lightest type of object, and you only need the rotation value, which is what this gives you. So it's the lightest way to just extract that data, essentially. So we're going to create an array. And instead of being a relative offset, which is, again, always relative and constant are going to be like in relation to the object itself, I don't want to rotate around or like extend from this object. I want to rotate around a specific object. So I will select it. Now right away, this is my duplicate. If I create more, it'll just keep offsetting more and more and more. So there's definitely a transform being applied to this. And if you move this to match this one, you'll notice how it like aligns those pieces. So let's just snap this to the center of the world. So now that the pivot of this object and the pivot of this object is the same, the scale is off on this object. So if we apply scale, we'll snap it back down to be the regular size, but we're still having an issue of all these duplicates being on top of each other. So because the array of this object, of this mesh, is being controlled by another object, in order to get this one to rotate, we need to control this other object. So I don't want to just straight offset it, of course, because that's going to give me the same result, and that doesn't look like a flower. But if you rotate in X, for example, or Z, sorry, then you can kind of control these flipping around this core. But I also have another issue of like all these leaves kind of on top of each other. So I don't really want to move in object mode, because if I do that, I'm going to start offsetting it, and that's not what I want. We already have the pivot correct, so I don't want to change that. So we're going to enter edit mode. And I know I want the tip of this petal to be in the middle here. So if I raise that up, that raises all of them. And then if I pull this one back, that's kind of pulling them apart. And then if I go from this pivot here and open it up the way a flower would be, if I drop these down, then I can get these to orient the way that I'm expecting to see them. And then it's a lot easier to see like the value that you would need to use. And then again, I still have this to control from. So you just got to be aware of object rotations for this type of thing, especially when you're stacking stuff together. So like putting geometry on a curve, or you're putting geometry with array using a locator to array it. Regardless of your situation, you want to make sure your pivots are in the same place, at least to start, because that'll help you see where the object is like going in its neutral way, and then you can like offset it after the fact, of course. But at least to start, make sure your pivots are the same. Make sure your object data is zeroed. Of course, reminder, like we saw in the case of the screw, that's not always what you want. If you zero out your scale, sometimes you'll get a very different result. But a lot of the time, a way to fix that is to either, one, apply it out, and then change your angle accordingly. Okay, here we go. This is the value. So I've zeroed it out. My scale is no longer being applied, so I just need to shrink this back down. Or, for example, or if you know like this is exactly how I want it, and I don't want to have to change the setting, I know I want this as geometry, I would duplicate this off, hide it, and then if you go to Object, Convert, and Mesh, you'll actually just collapse that down and basically apply it. And now when you apply your scale, you're not going to throw the modifier out of whack. So it's best to check your scale before you get too far in like setting your object, because you may find you'll have to change it after the fact. So same thing with solidify. Usually if I'm going to put a solidifier on something, or if I'm putting like a simple deform modifier, just make sure you zero this out first so that you get an expected result right away with the zeroed transforms, so that you don't need to like account for it after you apply those transforms, because in a production context you will be applying these scales and you're never going to pass anything forward that isn't applied. So long story short, just apply it first and then you won't have problems when you go through it. But if you do, no worries, you can apply it as a mesh, or I can even, for example, duplicate this off as a reference and then apply my scale and then bring this down. Is it this one? Yeah, okay, I'm just pushing it the wrong way. That's cool. And then you can like eyeball connect it, you know? And then the benefit too to making sure that you've zeroed out these transforms is that if I want to apply the same screw to a different object, like for example, I'm just going to duplicate this off, break this, and get rid of this. Okay, so let's say I have this completely zeroed object. If I copy this modifier, it's just going to completely go out of whack because this modifier is set for an object that has scale values. Whereas if I copy this one instead, it's going to be a lot, like again, this one still has a rotation set to it. So that's another way that it's like changing this this object in a way that is like different to this one. I've also changed the pivot, which is different. So that's just, it's very easy to accidentally change the pivot and your orientations. So something that's working 1 minute might suddenly break. And it's just, this is essentially a lesson to teach you how to troubleshoot, the things to look out for, and kind of how Blender thinks about it so that you can make sure that the values that need to be set to 1 are set correctly and the ones that need to be left alone are left alone. So yeah, that is how mesh transforms and object transforms and the location of your pivot and the orientation of your pivot can all affect how you model. And hopefully this made sense for y'all. If you have any questions, ask me in the comments and I will try to help. If you like this video, like and subscribe, and I will make more tutorials. I really want to get Blender artists, more Blender artists, especially converting them over from Maya, because Blender is fantastic and everybody needs to know Blender joy. So have a good day, y'all. Bye!